Welcome to another edition of ProSoft Technology Video Training. In this video, we're going to cover some of the most common causes of radio communication problems for industrial wireless systems. First, we'll go down the list of what you should check for if you're setting up 2 or more new radios that will not link or will only link intermittently. We'll then address what you should check for if you have an existing radio network that had been working but is now having communication problems. We also have another video that covers the 10 big considerations for specifying an industrial wireless system. Let's talk about what you should do if you're trying to set up a new radio network with 2 RLX2 radios and are having problems getting them to link. First, it's highly recommended that the initial configuration should be done on a bench, so all major components of the Wi-Fi system are easily accessible. This makes the configuration and troubleshooting process much faster and easier. The first thing to check are some of the basic configuration parameters. Be sure that you have one radio configured as a master and one as a repeater. This relationship between the 2 radios is necessary for them to communicate. Next, ensure that the security, or SSID, encryption type, and phrase are the same for both radios. If these settings are not exactly the same, the radios will not talk to each other. Once you've confirmed that the configuration is correct for both radios, check to be sure that the antennas are connected to the correct port on each unit. If you're using a radio model with multiple ports, you should connect the antenna to port A if you're only using one antenna. If you're using 2 antennas and you have a radio with 3 ports for use with a multiple input, multiple output antenna, they should be connected to ports A and C. On the radio's web configuration page, there is the Advanced tab to see active antennas. As a side note, if you're doing a bench test of your radios, you can simply use the articulated antennas that come with the product. But if you plan on using a mounted antenna when you deploy the radios, you must be sure that you're using the proper conversion cable to connect to the antenna. For our RLX line, this is a cable with an RP SMA connection for the radio. Moving on. If you have an existing radio network that had been providing you with adequate communication speeds, but now you're having problems, here are some things you should check. Right off the bat, you should check your connections and make sure nothing is loose. Then, determine if you have line of sight between the 2 or more antennas. For a radio link to function at its full potential, the line of sight between antennas must be completely clear. Now, an outdoor application may have had line of sight when it was initially commissioned, but there could be trees or other vegetation that's grown and become a problem. Also, keep in mind that anything that might move into your line of sight routinely, such as a crane, a truck, or other large vehicle, could cause you intermittent communication problems as well. So make sure your antennas are positioned where they will be clear of any possible interference. Next up, ensure that your directional antennas are oriented and polarized correctly. Yagi types should not be pointed up to the sky, for instance. They, along with parabolic, panel, and other directional type antennas, should be oriented to point at the receiving antenna. It's also important to ensure your antennas all share the same polarization, either vertically or horizontally. High winds can be a problem for certain antenna types, such as panels or dishes. Be sure that your antenna has not been tilted out of alignment. Another possible issue for outdoor applications is moisture getting inside the cables. This can happen if the weatherproofing has been compromised by age or if it was never actually used in the first place. For indoor applications with lots of metallic surfaces or objects that are reflective for radio waves, such as a factory floor or a warehouse, we recommend using MIMO antennas rather than more conventional types. They are optimized to perform in highly reflective environments and will be much more reliable. If your antenna line of sight is good, you should next confirm that you're using a clear channel. An increasing problem on industrial sites is the proliferation of wireless devices occupying all available frequency and channel space. So while you may have had a clear, dedicated channel for your wireless link when the system was commissioned, it's possible that other devices have since encroached on it. You can try taking the radio offline and use it to scan for what channels are in use. This is done by setting the radio to repeater mode, ensure that you're not connected to a master, and simply click the Available Parents button. This will scan the environment for RF signals and show data on all the devices that are out there, including what channels they're using. You can actually filter the results by channel to make things easier. So channels that are being used by many devices should be avoided if possible. The 802.11 standard does allow for different devices to share channels. When one is talking, the others must back off and wait until it's done. This way they don't all try to talk over each other. It does, however, mean that communication must slow down while devices wait for their turn to talk. The more devices on a channel, the slower it will become. So if your channel has become too crowded, you'll have to either switch to another, clearer channel, or kindly ask the overseer of the other devices to switch channels. Another possible problem for an existing network is that too many repeater radios have been added to the network, all talking to a single master. If you have several repeater radios or are moving a lot of data at a high rate, it's possible for there to just be too much traffic for the master radio to handle efficiently. You might need to segment the network between two masters, still using the same SSID encryption type and passphrase, but on different channels. Speaking of too much traffic on your network, it's also recommended to use unicast connections rather than multicast, which generate significantly more traffic unnecessarily. Another step you can take to streamline communication is to enable secure bridging. This is done through the Advanced tab, and it sets the radio to only communicate with other ProSoft radios, blocking any other devices that try to connect. Also, if you have a repeater talking to one or more other repeaters to extend the range of your network, be sure that each of the radios in the path are configured and linked together in the proper sequence. If there are multiple paths of similar length back to the master, repeaters may switch between them based on what path they detect is the shortest at any given time. If data is being transmitted as the link switches over, it's possible to lose some data. You can specify what radios you want to link together under the preferred parent settings on the web configuration page. Also, link time will show how long a repeater has maintained the link to its current parent. It's also possible that the data rate is simply too fast, and the radios cannot keep up with the RPI your devices are configured for. Make sure that RPI settings for your equipment is set no faster than what is actually required for your application. Those are the most common solutions to the problems we typically hear about. We hope that you found the video helpful. If you do find that you need assistance, feel free to contact our wireless field application engineers for professional help concerning your particular application. Something that is very helpful to us is for customers with wireless communication issues to provide an IH browser export file. From the IH browser, just go up to File and select Export. Then click Export in the window that comes up. This takes a snapshot of the network, and the file will help our support team to quickly determine the nature of the problem. Thanks for watching.